Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry the Mystery of Molecules. Today's topic of discussion is one MCQ about phenol. The question is in front of you. You have to say what is the major product after these three steps of reaction. Four options are provided. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Remember, self-evaluation is essential for improvement. And don't worry, after some time you will get the right answer with proper explanation. I believe you have tried by yourself, so it's my turn to give you the right answer. So let's start. If you look at this moiety, this is actually phenol, and this phenol is reacted three steps. And first step is student acetic anhydride and HF. I guess student, many of you have seen one reaction, that is if any alcohol react with this acetic anhydride in presence of any base like pyridine, triethylamine, it produces ester, means acetate ester. So this thing you are familiar. Now here, what is the role of this base? This base actually helps to deprotonate these OH such that ester formation becomes possible. So for this purpose, base is essential, and here what is provided? HF. It's not a base, it's a weak acid. Now just recall that instead of HF, if a Lewis acid is provided, what is the option? Obviously then the result is completely different, that is aromatic electrophilic substitution. So actually here a competition happens, that is ester formation versus aromatic electrophilic substitution. And if you look at this phenol moiety, this phenol can do three type of reaction. One, reaction through OH directly, and what are the other? Ortho substitution or para substitution. And if you look at little carefully, this ortho position has both minus I and plus R effect due to this oxygen, whereas this para position faces only the plus R effect, and this phenol is actually electron donating and activating for aromatic electrophilic substitution. That's why this reaction step is little crucial, student. Aromatic electrophilic substitution reaction happens, and remember this, since the phenol is activating in nature, that's why Lewis acid, presence of Lewis acid is not essential. So first step of this reaction is aromatic electrophilic substitution, or more specifically it's an acylation reaction on the para position. I believe this step is little crucial for understanding, so I guess you have understood. If you didn't understand, please go back and watch the explanation again. Now if you look at this, after this first step, this compound, it is actually one side is hydroxyl or phenolic hydroxyl and another side is ketone. We know that this phenolic OH is electron donating and this ketone is electron withdrawing. So this molecule is overall stable because electron delocalization happens throughout the molecule. So this is a relatively stable molecule. Fine. Next step is hydroxylamine hydrochloride and sodium acetate. Student, if you look at this hydroxylamine reagent, it is sold as hydrochloride salt because free amines have a tendency to undergo oxidation. So for that purpose, this lone pair of this nitrogen is blocked by protonation with HCl. Point number one, but it's actually hydrochloride salt, one unit acid is there, and if we want to form a ship base reaction or imine formation, and which will ultimately result this derivative, or it is known as oxime. So for that purpose we need to remove this HCl, and for that purpose one mild base is needed, and that's why this sodium acetate is used. Actually student, if you look at the hydrolysis of sodium acetate, what is the pH of the solution? It's slightly basic, means this salt is actually slightly basic in nature, that's why it is capable to quench the HCl. If I say more accurately, this sodium acetate is behaving like a buffer, and buffer means it's able to provide a relatively constant pH. So in that pH condition, this hydroxylamine reacts as a very good nucleophile because of alpha effect. Alpha effect means the lone pair of electron of this lone pair and this lone pair this repulsion makes them a better nucleophile or alpha effect. So that's why they are very much reactive to form this oxime derivative or ship-based derivative. So this oxime is produced, and the next step is, so this is actually significantly strong acid because of the minus I or withdrawing effect of this CF3 group. And SO2Cl means SOCl2 thionyl chloride helps to make this OH is a good leaving group. And what is the byproduct of the reaction? This OH and SOCl2, this is HCl and SO2, both are both are gas, so they come out from the reaction medium, and that is the beauty of this SOCl2 reagent. Now student, you may face the confusion that sir, there is also one OH, why this OH doesn't go? Remember student, these oxygen carbon bond is very strong because there is a back bonding, significantly strong back bonding. Okay, so that's why these will not break, rather than this OH will leave, and actually it will convert into a good leaving group. So, and this amber list is actually an ion exchange resin, so it's actually a completely acidic medium. So what can happen in acidic medium? OH converted into good leaving group, and these all moiety, so this aromatic moiety migrates from this carbon, so this is actually carbon atom, to the nitrogen, and this part leaves. So it is nothing but Beckmann rearrangement, which produces, you can see it's an amide of acetic acid. Okay, so more specifically versus analyte derivative, so this is produced. So what are the name reaction and key step associated with this process? First step is Friedel-Crafts acylation in presence of HFS acid. Second step is sheep base for condensation, or you can say oxime formation using hydroxylamine. And third step is Beckmann rearrangement. By the way, I have discussed many dedicated lecture on Friedel-Crafts acylation, sheep base condensation, and Beckmann rearrangement. And what is the final product? If you look at this, you can I guess remember its name is student N-acetyl-para-aminophenol. So can you now guess what is this compound? Yes, obviously it has a very famous market name, that is paracetamol. It's widely used medicine. So this is produced in this way. So this is actually a medicine preparation. I have already discussed a dedicated lecture for different method for paracetamol preparation too. Please visit if you have any doubt or interest. Now, so what is the answer? That is N-acetyl-para-aminophenol. So the option C is the right answer. Now, if this question appear in your exam less than 30 seconds, how can you solve? First of all, you need to understand what is the role of this HF. It is actually acting as acid. So acylation on this oxygen not possible, it will happen an aromatic electrophilic substitution, and this is possible in ortho para position. See student, anywhere I haven't mentioned ortho, so ortho will not happen, only para. So para substitution, fine, this thing. So option D is gone because no para, no ortho was a wrong option, gone. Second thing, so first of all it will happen and ultimately it will produce para-acyl substituted product. Fine. Now question, second step is hydroxylamine hydrochloride sodium acetate. So how can this is the product of first step, it will react, it cannot survive, so option gone. Third step, now remaining as only B and C. See student, in the first step I told that this acylation will happen on the ring, not oxygen, so this is also gone. So you don't need to go on the third step. I guess this amber list, this thing may be a little difficult, but if you understand the both first and second step and based on proper reasoning, option C is the right answer because all three options are gone. So in this way, using your common sense, you can come up to the right answer. But I always suggest student, please don't follow these tricks at the beginning. Study as much as you can, and after that you follow these tricks because those that will give you the success. Now, so in conclusion, what you have learned today, that phenol is activated for aromatic electrophilic substitution due to the plus R effect of OH group, and it is both ortho-para orienting and activating in nature. This ortho position faces minus I and plus R effect both, whereas the para position faces only the plus R effect because para is far away from the phenol, and we know that this minus I effect operates through sigma bond in short distance. Okay, so that's why para position faces the plus R effect only. And this hydroxylamine is a better nucleophile than ammonia for ship base formation due to alpha effect or lone pair repulsion. And this ship base is also, actually it's an imine, but it has a very specific name that is called oxime, because product of hydroxylamine is called oxime. So in presence of good leaving group, oxime can undergo Beckmann rearrangement to produce anilide. It's actually migration of this aryl group. Now, and finally, the paracetamol is actually active for both pain and fever reduction. It's an antipyretic, very useful medicine. So this is the end of discussion. I thank you all for watching, and if you really consider the content of my channel is worthy, then please help this channel to grow. So see you in my next video. Stay happy, stay blessed.